Hello, algebra students. In this lesson 3 of Unit 5, we're going to learn how to analyze geometric sequences and series. So, in the previous lesson, we learned about arithmetic sequences and series. And in an arithmetic sequence, we were adding the same thing over and over again. So, repeated addition, we talked about there being a common difference. Now, the geometric sequence or series, the ratio of any term to the previous term is constant. This constant ratio is called the common ratio and is denoted by R. Now, more importantly, and what would make more sense is common ratio means if I were to take one term and divide it by the term that came before it, I would continue to get the same thing. Or you could think about it as I'm looking at a sequence where the pattern is repeated multiplication. Okay, so take a look at this sequence right here, 2, 6, 18, 54, etc. The pattern as I move from one term to the next is I am continuously multiplying by 3. 2 times 3 is 6, and 6 times 3 is 18, and 18 times 3 is 54, and 54 times 3 is 162, etc. Okay? Now, if I had to think about how would I write a rule for a sequence like that, well, repeated multiplication by 3, right here I've got, to get 162, I had 3 to the 4th, right? So 3 to the 4th power. Well, if I want the 4th term, I was multiplying by 3 times to get that 4th term. If I wanted 18, well, that was the 3rd term. To get there, I had to multiply by 3 twice. Okay? So in this case, I had repeated multiplication by 3, which I'm going to represent as a power. 3 raised to a power. And I'm going to put an n up here for right now. Okay? Now, if I raise 3 to the nth power, it's going to tell me how many times I multiply by 3 to get somewhere. One part of writing out a formula for something like this is figuring out, well, where did I start? I started with a 2. Okay, I started with a 2, and then I multiplied 2 times 3, so however many times to come up with the next terms. Okay, so this is looking good, okay, but I want you to think about something. If I were to plug in 1 into this formula, which should give me the first term, 2, is that going to work? If I take 1 and plug it in, think about that. 3 to the 1st power is 3, and 3 times 2 is 6, which is the second term, not the first term. So I'm going to have to change my rule just a little bit here to accommodate that. Okay, so in order to accommodate the fact that I have my first term listed right here, and I'm not going to multiply by 3 until I get to the second term, I'm going to change my exponent to not just n, but n minus 1. Okay, now if you think about that, if I were looking for the 5th term, 162 is the 5th term in the sequence. Look how many times we multiplied by 3 to get there. Well, to get the 5th term, I had to multiply by 3, 1, 2, 3, 4 times. To get the 5th term, I multiplied by 3, 4 times, which is 1 less than the number of the term. Okay. Now, does this work if I plug in 1 now to get the first term of 2? Well, let's see. 1 minus 1 is 0. 3 to the 0 power is 1. And 1 times 2 is 2. Works out. Okay, we got that one. If I plug in 2, does it give me 6 for the second term? Let's see. 2 minus 1 is 1. 3 to the 1st is 3, and 3 times 2 is 6. We got the second term covered, okay? And you can check the rest of them, they're going to work out. Now, if that makes sense, and I hope that it does, that will lead us into the rule that we're going to use for geometric sequences always, okay? So once you got this, okay, this makes sense to me, well, this is the pattern that we're going to follow all the time for these kinds of sequences. If I want to find the nth term of a geometric sequence with a first term of a sub 1 and a common ratio of r, it's going to look like this. If I want to find the nth term of any geometric sequence, I am going to take the first term, a sub 1, times r, the common ratio, which will be raised to the n minus 1 power. Okay? So that's going to be the case. This is what they're going to look like. So if you can find the first term of the ratio, you can write out the rule for the sequence. That's all you got to do. So example here. Give me a rule for the nth term of a geometric sequence with a first term of 3, so that's going to be a sub 1, and a common ratio of 2, well, that's r. So here's going to be the formula I write for this one, or the rule. A sub n is equal to the first term 3 times the ratio 2 raised to the n minus 1 power. There we go. Okay, so let's do it down here. Write a rule for the nth term, find the 6th term. Okay, so I'm going to figure out my common ratio. Now, sometimes you can just look at it and know that, hey, 3 times 4 is 12, and 12 times 4 is 48, and that's fine. The other way to do that is to look for the common ratio is to take one term and divide it by the term right before it. So if I were to take, let's say, 192 divided by 48, okay, and I'd figure that out, all right, well, that's 4, okay, just trust it. And if I take 48 divided by 12, I get also 4. So again, that's the idea of there being a common ratio. So then, if 4 is my common ratio, when I write out the rule for this particular sequence, the nth term is going to be found by taking the first term, which again is 3, it's given to us, so 3 times the common ratio, which was 4, raised to the n minus 1 power. Okay. Now, if I want to find the sixth term, which is another part of the instructions, to find the sixth term, I'm going to plug in 6. Okay. So that's going to mean I'm going to take 3 times 4 raised to the, well, 6 minus 1 is going to be 5. So 4 to the 5th power. Now be careful. You don't take 3 times 4 first and get 12. Order of operations, we got to do exponents first. So I'm going to take 4 to the 5th power first, and then I'm going to multiply that by 3. Okay, and to save some time, you could type that into a calculator if you wanted to, but the answer that you should come up with is 3072. That would be the sixth term. Okay, so I got my rule, and I got my sixth term, like I was asked to do. Awesome. Next one, maybe a little tougher to figure out how we go from one term to the next. And you might say, well, it looks like maybe I'm dividing. Well, we don't like to divide, we want to multiply. So perhaps I'm multiplying by a fraction instead of dividing. So again, one of the maybe tough things here is to figure out that common ratio. Well, let's take a couple of these and divide them. What is 4 divided by negative 12? Right here. So what's the common ratio here? Well, 4 divided by negative 12, that's negative 1/3. Okay. What if I were to also do the same thing with negative 12 and 36? What's negative 12 divided by 36? Ooh, look at that. Once again, that simplifies down to negative 1/3. So negative 1/3 must be my common ratio. Okay. So when I write my rule, to find the nth term, I take the first term, whatever it is, in this case 36, times my common ratio. And here, because it's negative and it's a fraction, I'm going to put it in parentheses. So negative 1/3 is my ratio, and that's going to be raised to the n minus 1 power. So there's my rule. Okay. Now, if I'm going to use that rule to find the sixth term, again, that would be a matter of me plugging in 6 for n. And again, carefully doing this on my calculator, knowing that I'm multiplying by 36 at the end. I take negative 1/3 to a power first. And 6 goes in here. 6 minus 1 is 5. So negative 1/3 to the 5th times 36. That's going to end up being, we'll save you a little bit of time and just cheat and look it up. That's going to be negative 4 over 27 when you're all done with that one. Okay. So that would be defining some geometric sequences, showing you how to write rules, where the rules come from, and how to find specific terms within that sequence.